The 30, 60, 90 triangle is one of the special triangles you will surely come across in your exams. As the name suggests, one angle measures 30 degrees, one 60, and the remaining one obviously 90 degrees. So what's special about it? In 30, 60, 90 triangles, if we are given the length of one side, we can easily find the lengths of the other two sides. So knowing one side's length gives us the lengths of all the sides. Before you plan to memorize the relation between the sides, I urge you not to. All you need is to understand something very simple. The side opposite the smaller angle in a triangle is always smaller. So BC, which is the side opposite the 30 degrees, will be smaller than AB, which is the side opposite 60 degrees. And this will be smaller than AC, which is the side opposite the 90 degrees angle. This is the most basic thing we need to understand. The next concept is quite remarkable. These three sides will always be in the ratio 1:√3:2. In terms of variables, if we say that BC is A, then AB will be A√3 and AC will be 2A. Let's take a couple of examples. Let's say we are given that BC is equal to 2 units. Then based on this ratio, AB will be 2√3. Then AC will be twice this value, which is 4 units. Okay, here's another one. What if we are given the length of AB as 5√3 units? BC will be 5 units and AC will be twice of 5, which is 10 units. What if AB is equal to 2 units? This is interesting. If AB is 2, then BC has to be 2/√3 units. Look at it this way. This times √3 should give you AB. So 2/√3 times √3 is 2. AC will be just twice of BC, which equals 4/√3. But what if we forget this ratio? Can we quickly derive it? For that, you just need to understand the equilateral triangle well. Let's draw one quickly and name it ABC. All we need is to draw a perpendicular from A onto BC and call it AD. As all angles of an equilateral triangle are equal, this one will measure 60 degrees. These two will also measure 60 degrees. For now, just look at triangle ADC. As the sum of angles of this triangle will also be 180 degrees, we get this equation. This angle plus 60 degrees plus 90 is 180 degrees. Solving this, we get the measure of angle DAC as 30 degrees. So ADC is actually a 30, 60, 90 triangle. If the side of the equilateral triangle is S units, then we know that DC will be S/2 units. In an equilateral triangle, the perpendicular from a vertex to the opposite side divides it into 2 equal parts. Now in this triangle, if we are able to find AD in terms of S, we can easily derive a ratio. Using the Pythagoras theorem in triangle ADC, we get this equation. Solving for AD, we get its value as √3/2 times S. Now in this 30, 60, 90 triangle, we have all sides in terms of S. We are interested in DC is to AD is to AC. Side opposite 30, side opposite 60 and side opposite 90. DC is S/2, AD is √3S/2 and AC is S. Multiplying throughout by 2, we get S is to S√3 is to 2S. There you go. That's our ratio. 1:√3 is to 2. So if we forget the ratio, all we need is to draw an equilateral triangle, drop a perpendicular and solve for the sides of this triangle.